Hello, beautiful people. How are you doing? This is our second lecture video on this semester, and Miss Fatin misses you so much. In this lecture video, we're still talking about heat energy. Where does heat energy come from? Actually, there are many sources of heat energy. I know that you know lots of sources of heat energy, such as the sun, the toaster, a kettle, a candle, and a heater. Each one of these provides us with heat energy. In the sun, there are gases burning, so it's the chemical energy that is the origin of heat energy in this case. When there is something burning, we say that the chemical energy is converted into heat energy. A toaster needs electricity to work, right? So, the electric energy in this case turns into heat energy. And we have the same case for the electric kettle. It's the electric energy that is converted into heat energy. The candle, you can see a flame. So, there is something burning. The chemical energy in this case turns into heat energy. And this is an electric heater, so the electric energy is converted into heat energy. But are chemical energy and electric energy the only sources of heat energy? No, we still have a third type of energy, which is the mechanical energy. When we rub things against one another, we produce heat energy. Like when we rub an eraser against a paper, or when we rub our two hands against one another, we are producing heat energy, and in this case we say that mechanical energy is converted into heat energy. How does heat move? When two objects when two objects have different heat energy, heat moves from the hotter object to the colder object. In this case, the heat energy from the sun is the source of heat energy, so heat moves from the sun to the woman standing or sleeping in the sun. Look at the man standing in front or sitting in front of a heater. Heat energy moves from the heater, which is the hotter object in this case, to the man. A girl is holding a cold cup of chocolate maybe. So the hand of the girl has more heat energy than the cold cup. So heat moves from the girl's hand to the cold cup of juice or of chocolate. Do all materials let heat energy move in the same way? We said that heat energy moves, right? But different materials let heat energy pass through them in different ways. Some materials are called conductors because, such as metals, because they let heat pass through them easily, while wood, which is a thermal insulator, doesn't let heat pass through it easily. Metals are conductors since they let heat energy pass through it or through them easily, while are not woods are not conductors. They are thermal insulators or bad conductors of heat since they do not let heat energy pass through them easily. Metals such as gold, aluminum, iron, silver, and insulators of heat such as wood, plastic, papers, and much more. So we know now that heat moves between objects from an object to another when these two objects have different, if we can say, amount of heat energy. They have different temperature and heat flows from the hotter object to the colder object. But does heat affect objects when it moves from one to another one? We did an experiment and we will discuss the results together. If you want to make this experiment at home, you need the help of an adult. Don't do it by yourself. Here is what you need. You will need an empty glass bottle, a balloon, and a hot plate. Instead of using a hot plate, you can use a bowl of hot water, of boiling water. So you will place the empty bottle in the boiling water and not on a hot plate. After placing the balloon on the opening on the top of the empty bottle, place it on the hot plate or in the bowl containing boiling water. After a while, you will notice that the balloon blows up. Where did the balloon get the air it needs to blow up? What happened? Heat passed from the hot plate or the boiling water to the air that is inside the empty bottle. This glass bottle isn't actually empty, it has air inside. And heat energy moved from the hot plate to the air. When something gets hotter, it will expand or get bigger. So in here, the air expands or it gets bigger after it got heated, and it begins to expand upward into the balloon. It moves into the balloon, and this is why the balloon blows up. Heat affects gases. When we heat air, which is a gas, it expands. Heat causes gases expansion. What about solids? Does heat affect solids? We have another video to watch right here. Here is a metallic ball. The metallic ball is able to pass through the ring. It goes in and out the ring. We will heat the ball for a while. What do you think will happen to the metallic ball after heating it? So heat it strongly for 3 minutes, let's say. Let's try now to check. The metallic ball is unable, it cannot pass anymore through the ring. What happened to the metallic ball after heating it? It got bigger, right? Let's cool the ball down. When we wash it using cold water, the ball is cooled, it loses heat energy, and it is able again to pass through the ring. So, when something gets hotter, when the metallic ball gets hotter, it expands, it gets bigger. At the same time, when something gets colder, it will shrink, it will go smaller. How did heat affect the metallic ball then? Heat causes solids expansion. When we heat metals, they expand, they get bigger, and when we cool them, they get smaller, they shrink, they contract. Here is another video showing how heat affects solids. Here are the rails of a train. The rails of a train bend when they are heated. The rails of the train are made of metals and they are usually made of steel. Steel is a metal that expands when it's heated and contracts when it's cooled. If the rails of a train were connected to each other without any space, they will bend, and this will let the train go off the road. For this reason, the rails are connected in a way that keeps a space between the rails, and this allows the expansion when the metals are heated. Let's do this. We have Okay, this question is found in your book at page 135. We have a metallic rod and we have also a cylinder. Okay, and this cylinder is too tight. What can we do to let the metal rod go inside the cylinder? Should we heat the rod and the cylinder together so they will both expand? This will expand and this will expand. Should we heat the rod and cool the cylinder so this one will go bigger and this one will go smaller? Or we should cool this one and heat the cylinder? What do you think? I'll count till 5. Take your time to think. Yeah. 1, 2, 3, 4, and 5. So, what do we need to do to help the rod go inside the cylinder? The rod must be smaller and this should be bigger. To make things bigger, to help them expand, we heat them. So we should heat the cylinder and not cool it. And we should cool the rod so it goes smaller, so it contracts. So the correct answer is the last one. This one is the correct one. We should heat the cylinder so it expands and gets bigger, and we should cool the metallic rod so it goes smaller, and this way the rod will fit in the cylinder. Solids, liquids, and gases expand or get bigger when they are heated. Inside the hot air balloon, we're heating air so it expands and blows the balloon. When we cool the air, the balloon starts losing the air inside it. We have mercury inside the thermometer, which is a liquid metal. When it's heated, it expands. When it's cool, it contracts. It gets smaller. Heat also causes solids expansion. Look at the rails of the rod. When they are hot, they expand and they stick to each other. When we cool them, they contract and they get smaller. Does heat change matter? Does it change things? Yes, heat energy changes things. Solids, liquids, and gases expand when they are heated. They go bigger, they get bigger when we heat them. Let's talk about water for a while. Here is water, here is ice, which is solid, the solid state of water. When we place a bottle of water in the freezer, the water freezes. So the liquid water turns into solid water. We're still talking about water in here. The water that you drink right here is in its liquid state. When you place it in the freezer, it turns into its solid state, which is the ice. When we cool a liquid, when we place it in the freezer, it changes into a solid. At the same time, when you leave an ice cube on a table, for example, the ice cube will lose its heat energy and it will melt. So the solid ice right here, this solid thing, the solid ice cube will melt and turns into liquid, into water. So also heating a solid, when we heat, when we do the opposite thing, instead of cooling water, we are heating the ice. When we heat a solid, it changes into a liquid. When we heat a liquid, it evaporates. So water changes into water vapor. The liquid water changes into gas water, which is the water vapor. Liquid changes into gas. When a liquid changes into solid, this process is called freezing. So freezing is the process when we cool a liquid and change it into a solid. Heating a solid changes it into a liquid, and this is called melting. The solid turns into a liquid, so the solid melts. The last process is the evaporation process, and during this evaporation, we heat a liquid to turn it into a gas.
Water is one of those rare substances that can be easily observed in all three states of matter: solid, liquid, and gas. It is in its solid form at temperatures lower than 0 degrees Celsius, liquid when the temperature becomes positive, and gaseous above 100 degrees Celsius.
Let's take a closer look on this change. How does water change its state according to the change of temperature? I will run the temperature. Here is an ice cube. Let's heat the ice cube. Look, the temperature is increasing. We are heating the ice cube. Solid water changes into liquid water. So when we heat solids, they melt. This is melting, and they turn into liquid. The temperature is increasing. More heat energy is given to the water. And pay attention. At 100 degrees, liquid water changes into gas. This is water vapor. So liquid water is evaporating. This is evaporation, which is the process of changing liquid water into gas water. What did we talk about today? We talked about heat. Heat changes matter. Solids, liquids, and gases get bigger when they are heated. They expand. What are the three states of matter that water can take? Water can be solid, ice. Water can be liquid. It's the water that we drink. This is the liquid state of water. And it can be gas, ice. This is solid, liquid, and gas. Solid water, liquid water, gas water. Heat changes water from one state to another. When we heat a solid water, it turns into liquid, it melts. This is melting. When we heat water, it evaporates. This is evaporation. But when we cool liquid, we freeze it. This is freezing. That's it for today. If we still have any questions about the lesson, please send me messages and I will be happy to answer all of them. I love you. Bye bye.